before collision, before impact. So which is that, then you can use that because now we have got this, then you just substitute and get the answer there. Okay? So can you
Excuse me, sir.
Yes, please.
It's, now, how can I get this lesson that you have now taught? Because I've failed even.
Yes, I'm going to upload the video. I'm going to upload the lesson, okay?
Okay.
But nevertheless, nevertheless, but in the process, we are going to get all the concepts if you pay attention, okay? Okay? If you pay attention,
okay.
Yes. So Brenda, you first be working it out, Brenda. Brenda, get first the velocity of the bullets.
Excuse me, sir.
Yes. Yes, please.
Excuse me, sir.
I'm getting you, please.
As they are doing that.
Yes.
As they are doing, when you help me and first go over what that in the beginning.
Let me first check these people here who are not coming because they're texting me on WhatsApp, okay? Let me see how I can help them. Be checking, be going through the work period. Let me try to check your friends here. Okay, now to find the velocity of the bullets before impact, we use the principal conservation of momentum. So we said mu, where u is the mass of m is the mass of the bullets, then u is the initial velocity plus m, because remember the final velocity is 0. I mean the initial block was initially was at rest, so it becomes times 0 equals to m plus capital M and now the common velocity which we have got. So we find out we shall have. I said you change first change. You first change the 50 grams to kilograms, which is going to be 0.05 times the velocity that we are looking for, u, then this is 0 equals to 0.05 plus 8 times the common velocity. For common velocity we have got is already here. We have got it is 2.5620 times that. So we shall have 0.05 u equals to, so this one will give us 8.05 times 2.5620. So when you multiply that, what do you get? 8.05 times 2.5620. You find out we shall have 0.05 u equals to 20.6241 divide all through by 0.5 divide all through by 0.05. So this one will disappear. So you find out our u will be equals to, so divide this one by 0.05. What do you get? We shall come out to 400 and what? 412.4.482 meters per second. So that's the velocity of the bullets before impact. Before impact. Okay. Yes, Baptist. Baptist. Baptist.
Yes.
What happened,
Yes.
Baptist? What happened?
Maybe I connect. I joined to a different classroom.
Hey,
It was maybe for linear momentum.
hey, you are joining a wrong
Maybe-
lesson.
Yeah.
Okay. Sorry.
Yes.
All right. I think we have answered the question because they want us to calculate the velocity of the bullets, assuming that it gets embedded in the block just after collision. So after giving the sketch like that, we have done the calculation. There we are. So this is what they wanted. So this is what we wanted. So Apire.
Yes, sir.
Now for you, let's go through this question
Yes.
together. Let's go through this question number 2 together. I believe you will understand everything from there. Okay. Let's go to question number 2, members. Let's go to question number 2. Let's go to question number 2. The sketch is already there for me. I'm not going to sketch it. I'm not going to sketch it again. They're saying a steel ball of mass, M is attached to an inelastic string of length 0.6 meters. The string is fixed to a point P so that the steel ball and the string can move in the vertical plane through P. The string is held out at an angle of 60 degrees to the vertical, that's the angle of the swing, and then release. At the Q below, the ball makes a perfectly inelastic collision with a lump of plastiline of mass 2m. The mass is 2m, so that the two bodies move together after collision. So that one, they're just repeating what we have already said. They're just repeating the statement we have already discussed, because that explains what we call a ballistic pendulum. That what discuss what we form a ballistic what? Pendulum. So there we are. So for this one, they have given everything here. They have the sketch before and after impact. This one they have sketched before and then what? After impact. So this one, we have this one here. So this is 2m, the mass is 2m. So it's suspended. A pendulum is suspended to a given height. So this one I've said is m. So we are there like that. Apire, let me hope you are following me now, Apire.
Yes, sir.
Then this is it. Before, the ball was released to a given height edge. So this is small edge. So this is small edge, which was given there. So it's now swinging. So when it's in the process of swinging, it got stuck. Now they were moving with a common velocity. They were moving with a common what? They were moving with a common velocity. So this is m. Then now this is 2m. That is 2m. Now all combined. Now the vertical height after impact, now they will move with the what? So now this one, they have called it edge. That is edge. That one will not change anything. So this angle, they've said is 60 degrees. So we don't know the angle of the swing. We don't know the angle of the swing. But this length here was given to be 0.6 what? Meters. This one was given to be 0.6 meters. Okay? Was given to be 0.6 meters. So you can see that. So this one must, sorry, This one should have gone higher than that. Sorry, I made a mistake when I was sketching because it's now swinging. So this angle, we need to find this angle here. Let's call that angle beta. Let's call that angle beta. So now they want us to calculate the velocity of the composite just after collision, But we need to know this height h. We need to know this height, the small h here, this one here. How can we calculate that height h? We say that height h is given by the length, which is L, into 1 minus cos theta, where theta is the angle of suspension, theta, which is 60 degrees. So our so let me use a different value here. So theta is given to be 60 degrees. So h will be equals to the length, which is 0.6 into 1 minus cos of 60 degrees. So what you find that this small height h here will be, so let's work it out, 0.6 into 1 minus cos of 60. We find out we shall get 0.3 meter. So which means this ball here, this steel ball here was adjusted, was pended to a height of 0.6, then release. But they want us to find the velocity of the composite, which means they're asking us to find a common velocity. They want us to find a common velocity. But we said first to find that common velocity, what do we need? What do we need to find that common velocity? What do we need to find that common velocity? What do you need to find that common velocity? Members, Brenda, for you were there. What do we need to find that common velocity? V. So the first thing is we need to know the velocity of the bullets. Was the velocity of the bullets given in the question? Was it given? The velocity of the bullet, was it given? It was not given. So the velocity of the bullet was not given. So the speed of the bullet, I mean the speed of the steel ball, sorry. The speed of the steel ball at which was released. The speed of the steel ball was not given. So we said let that one be u. That one means before impact. So for us to find that, so we said from the principle of conservation, from conservation of momentum, and we said momentum is only conserved when the body is in horizontal plane, is on horizontal plane. So which means it's going to be mass of that times u plus, remember this one was initially at rest. So which means it will be 2m times 0. 2m times 0 equals to after will be that we move together with the common velocity will be m plus 2m times the common velocity v, because now they move with the common velocity. But how do we find that common velocity? V? But we said first to find that common velocity v, to find the common velocity. So let's first simplify this. So we shall have mu equals to, this one will be 3mv. So we find that the m and the m will cancel out. The m and m will cancel out. Then we shall remain with u equals to 3v. M equals to 3v. So which means first to get v, u is equals to 3v. So let me make it a star there. I don't know that. So the only thing remaining is to find v. But how do we find v now? So the common velocity. The common velocity after impact. So that one we said we use the principle of conservation of mechanical energy will be conserved. That one mechanical energy will be conserved. So which means potential energy lost is equals to kinetic energy. What? Gain. Is equals to kinetic energy gain. Sorry. So will be equals to kinetic energy gain, but potential energy is given by mgh equals to, this is a half mv squared. Remember they are combined system. So we say the velocity v will be equals to, if you remember very well, which we are just repeating it, this m and m will cancel out. So we shall have 2 GH under the square root, if you remember that. So V will be equals to the square root of, but what is this height h? This height we have already calculated. We have already calculated that height. We have already calculated that height. We have already calculated that height. We said is 0.3. Is 0.3. Is 0.3. So which means our V our V will be equals to 2 times 9.81 times the height which we have just got is 0.3. 0.3. So our V will be equals to, can you calculate for me that? 2 times 9.81 times 0.3. Get the square root of that. You find it will get 2.4261 meters per second. So that's the velocity. That's the velocity. So that's the mass, that's the velocity of mass m just before collision. This is before collision, but they want us to find the velocity of the old system here, So when we look at this one, it's from where? It's from here. It's here. So U is equals to 3V. So we have already calculated U. We have already calculated U. We have already calculated U. So can you substitute and get us the final velocity of the combined system? This is supposed to be U, sorry. This is supposed to be U. This one is supposed to be U. This one is supposed to be U. Because we are using this, we are using at point A. We're using at point A. We're using at point A. So which means our V, so from U equals to 3V. U equals to 3V. So which implies that V is equals to U over 3. U over 3. So V is equals to 2.4261 divided by 3. So our V will be equals to 2.4261 divided by 3, which will get us 0.8087 meters per second. So this is the common velocity they were looking for. So this is the common velocity they were looking for. Are we together, members? Are we together? Yes. Then they want us to find the position of the composite, the position of the composite mass with respect to point Q. With respect to point Q, when the first mass comes to rest. When the first mass comes to rest. So that one we still also go back to the principle of conservation of. But now we are at this point here. We are at B. We are at B. We are at B. We are at point B. So still using the principle of conservation of momentum, of energy, sorry, at point B. Potential energy lost, kinetic energy loss is equal to potential energy gain. Okay? So we shall have. So now at B, at point B will be equals to kinetic energy lost is equals to potential energy gained. Is equals to potential energy gained. So we are just playing around with the formula there. If you remember the swinging pendulum, how mechanical energy is conserved. So if that is true, so which means I have mv squared, because that one is now after the impact. That one is taking place after the impact. Equals to is equals to mgh is equals to mgh is equals to mgh. Remember, we are looking at combined system here. We are looking at the combined system. We are looking at the mass of the combined. So this is for combined mass. Says combined masses. So you find that this and this will also cancel out. That one also cancel out. But now at the point B, the height is now capital H. So now this one, so we shall have, it implies now I have V squared equals to GH. Now this height, so H will be equals to capital H. Okay? will be equal to capital H according to the diagram, according to what they have drawn for us on the diagram. So which mean the height they want us to find, the height will be equals to, so we shall have H equals to V squared over 2G. V squared over 2G. But V we have already calculated. We said V is equals to 0.8087 meters per second. So it implies now our H will be equals to V, which is 0.807 squared divided by 2.9.81. So what will be the height H? So we shall have 0.8087 squared divided by 2 times 9.81 plus that. So we find we shall have the height will be
0.0333.
yes.
Yeah.
So
0.333113.
3 like that to 4 decimal places meters. What? Meters. So that's the answer. That is the answer. Then in part 3, they're saying the composite mass now oscillate above the point P. State the possible reasons why the composite masses come to rest. So the factors that will make it to come to rest, eventually the mass will come to rest is one is because of the frictional force. Is because of the frictional force.
Yes.
Is because of the frictional what? Force, and then what? Air.
Meters.
Air what? Air resistance. Those are the reasons why the system will come to rest. That's the reason why the system will come to rest. As simple as that. As simple as that. Okay? Brenda?
Yes, teacher.
Are we together?
Yes.
So these calculations are not hard. So once you have got the concept how we generate them, just a matter of playing. So for this one, why we consider this one? Because the ball was not like a bullet. This is not like a bullet. This was, again, the ball was first suspended to a given angle, then released. Then what? Release. So that's why we have to cut it for that height. We have to cut it for that height. So that's why it's different from when the bullet is fired. Okay? So let's go through some of this exercise. So revision now. So let's just do some revision. Let's do some revision now. Question number one. So Brenda, can you take us through question number 1? Brenda, can you take us through question number 1?
A bullet of mass 40 kilograms is fired horizontally into freely suspended block of wood of mass 1.96 kilograms attached at the end of an inelastic string of length 1.8 meters. Given that the bullet gets embedded into the block and the string is deflated through an angle of 60 degrees to the vertical, find the initial velocity of the bullet.
So we have to sketch. We have to what? We have to sketch. You have to give a sketch of that. So in exam, you don't need to follow all other steps we are discussing. So you just put like this, okay? Just put like this.
Okay.
So this one was, this is where the block is, right? This was before. That's why I'm
Yes.
using it. That's why I'm going to combine all of them here. So what was the mass of the block? Is 1.96 kilograms. Okay. So when a bullet was fired from here, so this is where the bullet was fired. So what was the mass of the bullet? Is 40 grams. 40 grams. And it was moving at which velocity? We don't know. The speed we don't know. So is u. Is what? Is u. So when you get here, it got embedded. It got embedded. So let's say up to that point like that, it got embedded. So the bullet is inside now. This time the bullet is inside. To a given height edge. To a given height edge. To a given height what? Edge. Yeah. So this height is edge. Then here they are moving now. It will move with a common. It will move with a common velocity. It's moving with a common velocity what? V. As this one is suspended to which angle here? Angle what? 60 degrees. To 60 degrees. Up to this point. Now this is the new position. That's the new position. Have you seen that, Brenda? Have you seen that, Brenda?
Yes, teacher.
Brenda and Baptist. Are we together, Brenda and Baptist?
Yes.
Yes.
All right. So now, after giving that sketch, the rest we know how to handle them now. The length, what is the length of the string? The length of the string was given to be 1.8 meters. 1.8 meters. So find the initial velocity of the bullets. Find the initial velocity of the bullets. But we said first to find the initial velocity of the bullets, what do we need? So the first thing is to find the what? Is to find the velocity, the final velocity V. To find the final velocity what? V. So let's find the height h. So we can say from h equals to L into 1 minus cos theta. So which means h will be equals to the length is 1.8 meters into 1 minus cos of 60 degrees. So which means our height h will be equals to 1.8 into 1 minus cos of 60 degrees. What do you get? Is 0. What? 0.9. 0.9 meters. So that's the height. This is the height. But we said, but the velocity v is given by what? The square root of 2g what? 2g h. If you have forgotten, you work from the first principle. If you have forgotten, you work from the first principle, but you still arrive to the same formula. So which means our v will be equals to the square root of 2 times 9.81 times the height, which is 0.9. So v, which is equals to, can you find for me that? So 2 times 9.81 times 0.9. What do you get? What do you get? Yes? What do you get, members? Is 4.2, right? 4.2021 meters per second. Brenda, is that what you have got? Baptist, is that what you have got?
Yes.
So that is the final velocity. That's the final velocity of the bullet of the combined system. This one V here after the impact. But the question was, the first question was asking for the initial velocity of the bullets. So for us to find the initial velocity of the bullet, we said we use what? From the principle or from the law of conservation of what? Of momentum, not so. Of what? Of momentum. So which means I have mu plus the bullet, the wood was at rest. The wood was at rest. Times 0 equals to m plus the capital M times the common velocity v. Times the common velocity v. So which means I have, what was the mass of the bullet? Is 40 grams, not so. So 40 grams, if you change it to kilograms, what do you get? You get 0.004. times U that we are looking for plus 0 equals to 0.04 plus the mass of the wood, which is 1.96 times the common velocity V. But V we have got is what? V we have got is 4.20021. Do what? 21. So we shall have 0.04 U equals to, so 1.96 plus 0.04, that one will give us 2. So 2 times 4.201. So we shall have 0.4 U equals to, so we shall have 2 times 4.2021, which will give us 8.4042. So divide all through by 0.4. Divide all through by 0.04. So our U will be equals to, divide the answer by 0.04. What do you have? 200 and?
210.105
0.105 meters per what? Meters per second. Have you not answered the question? Have you not answered that question? We have answered it, right?
Yes.
So we have 4 minutes remaining. Can you do for me number 2? Do for me number 2, please. Do for me number 2. Brenda?
Yes, teacher.
Can you do for me number 2? In this remaining minutes,
okay.
we have 4 minutes remaining. 4 minutes remaining. Start working for at number 2. Work out number 2.
Okay.
Baptist?
Yes.
Work out number 2.
Yes.
Work out number 2, please.
Okay.
So in question 2, they want you now to find the angle theta, the angle of the swing. The angle of the swing. So they want you to find this angle here, this one. I remember explaining you how we get that angle. What? Angle. So how are you going to get that angle, Brenda? We said this one is L cos what? L cos theta. Then we said the length L is equals to L cos theta plus H. Then just play around with that. Just play along with that. So which means we shall have L minus H equals to L cos theta. So divide all through by L, divide all through by L. So we find that cos theta is equals to L minus H over what? Over L. That's also another formula you can use. So you find now for question number 2, the shortcut we shall have cos theta is equals to what? L minus H over L. So cos theta will be equals to, what is our L? Brenda, what is our L? Brenda, what is our L? The length is what?
1 meter. 1 meter.
It was given to be 1 minus, what's the height? Have you got the height?
No.
The height was not given, eh? So minus h over 1. But we said h is given by, you can just play around with that formula. You don't need to worry. But h is equals to L into 1 minus cos what? Cos theta. Cos theta. Okay? Put it back here. Put it back here. So even let me first put it back there. So should be from L equals to L cos theta plus, you find that it will cancel out everything. It will cancel out everything. It will cancel out everything. So this approach will not work. This one will not work because we don't know the height edge. This one need when you know the height edge. Okay? Okay? Members, this one you need to when you know the height what? Edge. So what you need to do from here, first find the common velocity. First find the common velocity. So we said common velocity is also the same as the square root of 2g L into 1 minus cos theta. Minus cos theta. So find for me this common velocity here. Find for me this common velocity v. So v is equals to the square root of 2g L into 1 minus